Hello students, let's read this problem together. Mel measured the diameter of several cans to make sure there was enough space in his pantry to store them. The result of his measurements are shown below. Calculate the ratio between the circumference and the diameter for each can. So again in the question it's saying calculate the ratio between the circumference and the diameter. So we are going to do the circumference to the diameter, which we will write as the circumference divided by the diameter. And we're going to do that for each circle to see what we get. So let's start with our first circle. We have here labeled the diameters. That's going to go in the bottom for each ratio. And then we have the circumference. That's going to go on the top of each ratio. So for my first circle, I have 21.98 over 7. For my second circle, I have 31.4 is the circumference divided by 10. For my third circle, I have 40.82 over 13. And for the last circle, we had a circumference of 50.24 and a diameter of 16. Okay, when we are going to simplify this ratio, we're going to divide. We're going to divide the numerator by the denominator. So let's start with our first one. We have 21.98 divided by 7. 7 goes into 21 3 times. We bring down the 9. We bring up the decimal. 7 goes into 9 one time. That's 7. 2 left over, so we bring down our 8. 7 goes into 28 4 times. And we are done. So for 21 over 98, we get 3.14. Okay, for our second circle, we have a circumference of 3.14 and we have a diameter of 10. Okay, so once again, we are going to divide the circumference, 31.4, by the diameter of 10. So our decimal needs to come up to the quotient line. 10 goes into 31 3 times. That's going to be 10 times 3 is 30. We subtract and get 1. Bring down a 4. 10 goes into 14 one time because 10 times 1 is 10. We'll have 4 left over, so we're going to add a 0 to bring it down. And 10 goes into 40 4 times. And that gives us 40. So we are done. And for this circumference divided by the diameter, we got 3.14. Okay, for our third circle, we had the circumference of 40.82 and we had the diameter of 13. So we're going to divide the circumference by the diameter. So we will do 40.82 divided by 13. So 13 goes into 43 times because that's 39. We'll have 1 left over and we bring down our 8. Let's not forget to bring our decimal up to the quotient line. 13 goes into 18 only one time. 13 times 1 will give us 13. We still have 5 left over, so we bring down the 2. 13 goes into 52 4 times. That'll give us exactly 52, and we are done. Are you starting to see a pattern? We have all these different circles, and every circle so far has given us 3.14. Can you predict what we will get for the ratio of the circumference to the diameter for that last circle? You think it's going to be 3.14 again? Let's find out. So for our last circle, we have a circumference of 50.24 and we have a diameter of 16. So we are going to divide 50.24 divided by 16. Now I know you're thinking, we already know it should be 3.14. Let's prove it. 16 goes into 50 if we are correct 3 times, and that would give us 48. We would still have 2 left over, so we bring down 2. We must bring this decimal straight up. And now 16 goes into 22 only 1 time. So 1 times 16 is 16. And we subtract. And we have 6 left over. We bring down the 4. And 16 goes into 64 4 times. That'll give us 64 exactly. And so we will be done. And so the ratio of this circumference to this diameter is 3.14. So we had 4 different size circles, and each one, when we took the ratio of the circumference to the diameter, we got 3.14. This is a special ratio. This ratio is called pi. It looks like this. So pi is what we get for every and any circle when we divide the circumference by the diameter. That ratio will always give us pi. And pi we estimate to 3.14. And we have seen here that when we took every circumference that they gave us and divided it by the diameter for that circle, we got 3.14. Our answer is B. It is also pi.